Okay, so in this video, we're going to pick up where we left off. Okay, so in the previous video, we graphed sine with amplitude changes. Okay, as we can see here, remember we talked about how the amplitude is affected by the value of a. Okay, and I did show you guys, show you how we find the period in the x scale, but we didn't actually do any examples where it changed. Okay, well, I'm going to cover that right now. So let's say we had this graph here, y, or this function here, y equals 4 sine of 2x. What I want you to do is pause the video and try to find these four values. Okay, and actually I'll tell you that the midline we haven't changed yet. I'll show you guys in the next video. The midline is going to be y equals 0 for these videos. But go ahead and pause the video and try to find these other three. Okay, hopefully you did that. The amplitude, remember, is the absolute value of a. A is 4, the absolute value of 4 is 4. Now the amplitude and midline together help us figure out what the y scale should be. So I'm actually going to change this now. Well, the amplitude is how far above and below the midline I need to go to hit my maximums and minimums. Okay, so I should probably go to 4, negative 4. Because I got to go up 4 from the midline, and I got to go down 4 from the midline. And you can go by ones if you want. I'm just going to have 2 hash marks and go by 2s. You could have 4 hash marks go by ones. It doesn't necessarily matter as long as you're consistent. Now the period and the x scale, these are going to change here. Now the period, remember, is 2 pi over the absolute value of b. And the absolute value of b is 2, the absolute value of 2 is 2. So it's going to be 2 pi over 2, which actually reduces to pi. So what that means is that one full scale is actually going to only take pi. It's been cut in half. Okay, normally it takes 2 pi to complete a full cycle. Now it's actually only going to complete it in pi because of this 2. And that also affects what our scale should be. If we don't change our scale, then our graph might look a little wonky. Okay, remember this x scale, we take whatever the period is and divide it by 4. And pi divided by 4 is literally just pi over 4. I don't need to reduce that at all. That's always how we find the period, or excuse me, the x scale. Take the period divided by 4. So that's exactly what I'm going to do. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4. And then I add another pi over 4 to get 3 pi over 4. And I add another pi over 4 to get 4 pi over 4. And you should probably reduce the ones that you can. Okay, so notice that I can actually reduce 2 pi over 4 to pi over 2. And I can reduce 4 pi over 4 to pi. So I'm going to reduce these, but that's how we find the scale. Okay, and now we start our pattern. Remember, sine always starts at the midline. And then as long as it isn't reflected, this one is not reflected, we go up to our maximum. And the only way to go from our maximum is down, so then we go back down to our midline. Then we go down to our minimum. And the only way to go is up from the minimum, so we go up to our midline. And this, try to make this as smooth of a curve as possible. This would end up being one cycle of this graph. I can continue it forever in either direction. If I wanted to, I can keep adding pi over 4 and just keep going. Okay, I can go further and further and further to the right. If I wanted to, I can go to the left, subtract pi over 4. And keep going further and further and further to the left. It doesn't necessarily matter for my purpose. As long as you can graph one full cycle, I am happy. Okay, so that is one example of that. Let's go ahead and try another one. Okay, so let's try something like this. Let's go ahead and let's do y equals, let's do negative 2 sine of 1/4 x. Okay, what I want you guys to do is go ahead and pause the video and try to determine what the amplitude period, try to find all that information, and if you want, go ahead and do the graph as well. Go ahead and pause the video and do that. Alright, so hopefully you did that, so I'm going to go ahead and start working this problem out. So the amplitude is the absolute value of a. In this case, that would be 2. The absolute value of negative 2 is 2. Remember that negative means that we're going to reflect over the x-axis. Reflect over x-axis. That's what that means. It's going to change the pattern up a little bit, okay, but it doesn't change how we find these values. Okay, the midline is still y equals 0 for the purpose of this video. Now the period would be 2 pi divided by the absolute value of 1/4. Remember, when you're dividing by a fraction, just multiply by the reciprocal. The reciprocal of 1/4 is 4. So this ends up becoming 8 pi. Okay, that becomes up 8 pi. And to find the scale for x, we take whatever the period is and divide it by 4. So 8 pi over 4 gets us 2 pi. Okay, so let's go ahead and get this graph going. Oop, I don't like that line. That's better. Okay, so remember, our midline and amplitude help us figure out what our y scale should be. I got to go 2 above the midline, which is 0. So I got to go up to 2. I'm going to go by 1s. And I got to go 2 below the midline to -2. Now the x scale, I'm going by 2 pi, so I'm adding 2 pi each time. So 0 plus 2 pi is 2 pi. 2 pi plus 2 pi is 4 pi. 4 pi plus 2 pi is 6 pi. And 6 pi plus 8 pi is, 6 pi plus 2 pi is 8 pi. Okay, and now we go ahead and graph this. Sine always starts at the midline, always. Okay, and now normally we go up to our maximum, but because we're reflected, we're actually going down to our minimum, and then up to our midline, up to our maximum, down to our midline. So this here would be one full cycle of the graph. Drawn a little bit better, hopefully, on your paper, but this would be one full cycle of the graph, okay? And that's how we graph sine with period and amplitude changes. In the next video, we're going to go ahead and take a look at how we can also affect the midline, okay? So make sure you check that out.